In this video, we're going to price bonds using a technique called bootstrapping. In the last video lecture, we looked at how to price treasury bonds using strips. Unfortunately, strips are not available at all maturities, so we have to find an alternative way to price bonds. We're going to do that with bootstrapping. The goal of this video is to price the 3% 757-day note. This is the same note that we valued using strips in the last video. Here we have the timeline for the interest payments and the principal repayment on this note. What information do we need, though, to price this note? We need discount factors. We need to know how to bring all these cash flows back to the present day. How many discount factors will we need? Well, we're going to need a discount factor to bring back the cash flow at day 27 to the present day. We'll need one for day 208, for day 392, for day 573, and day 757. What we're going to do to calculate the discount factors is use the prices of other notes and bonds issued by the US government. Because we need 5 discount factors, we're going to need 5 different bonds. And we're going to need to find notes or bonds that mature at all the different times that we need discount factors for. So we need to find a 27-day discount factor. For that discount factor, we need to find a note or bond that matures in 27 days. For the 392-day discount factor, we need to find a note or bond that matures in 392 days. And the same for all the other days where we need discount factors. And here we have 5 different notes that mature on each of the days when we receive payments from our bond. All these quotes are taken from the Wall Street Journal, and we're going to use this information to calculate discount factors. Whenever we use bootstrapping, we first have to calculate the discount factors with the shortest maturity, and then work our way towards the discount factors at longer maturities. Let's start with the 27-day discount factor then. To calculate the discount factor, we first need to convert the quoted price into decimals, and the quoted price was 100.03. That's in 30 seconds. When we convert it, 3 divided by 32 is equal to 0.09375. So the price in decimals is 100.09375. In dollars, that's going to be $1,000.9375 if the par value is $1,000. Now, what's the price today equal to? The price of this note is going to be equal to the present value of the coupon payments plus the principal minus any accrued interest. Why are we subtracting accrued interest? Well, remember, the Wall Street Journal quotes are clean prices. That means we have subtracted the accrued interest. We know that the coupon is 5.625%. That means in dollar terms, if the face value is $1,000, the coupon payment is going to be equal to $56.25. But coupons are paid semi-annually with government notes. So the payment that we're going to receive in terms of coupon in 27 days is 28.125. Now we've got to worry about accrued interest. We own the bond for 27 days out of the 184 days since the previous coupon. The accrued interest is going to be over the previous 157 days. Now let's see if we can calculate the discount factor. We know that the price today, 1,000.9375, is equal to the present value of the coupon plus the principal minus the accrued interest. Well, the principal is easy. That's going to be $1,000. Plus, well, how much do we get of the coupon payment? We're going to get 27 days divided by the 184 times by the coupon payment, 28,125. We can simplify this. The price today is equal to the present value of $1,004.127. How do we calculate the discount factor? The discount factor has to equate the price today with the future cash flows. The price today has to equal the discount factor for 27 days times by the future cash flows that we will receive, which is 1004.127. If we divide both sides by 1004.127, we get the discount factor for 27 days, which is equal to 0.99682. That's the 27-day discount factor. Now let's try and calculate the 208-day discount factor. Again, we have a note for 208 days, and the price of that note is 98.84375 when we convert to decimals. In dollars, we're looking at a price of $988.4375. Again, we know the price today is going to be the present value of the coupons plus the principal minus any accrued interest. The coupon payment is going to be $23.75, but it's paid semi-annually, as with all government notes and bonds. So the payment that's going to be received every 6 months is $11.875. Once again, we have to deal with accrued interest because we only own the bond for 27 of the 184 days before the next coupon payment. That means the price today, $988.4375, is equal to the discount factor for 27 days times by, what do we receive in 27 days? Well, we're going to receive some of that coupon payment after we've subtracted the accrued interest. So that's what we're doing here, calculating the fraction we receive. This is what happens in 27 days, but we also then have to think about what happens in 208 days. And we have a discount factor for 208 days times by the cash flows that we receive then. And we're going to receive par value of 1,000 plus the coupon payment. We already know the discount factor for 27 days. We calculated that earlier. Let's substitute in that information. The discount factor was equal to 0.99682 times by 27 over 184 times by 11.875 plus the discount factor for 208 days times by the cash flows in